Okay, today is technically 9.4 binomial theorem day 2, and we're only going to do 2 days on this because I explained it pretty thoroughly the other day, but I never actually showed you the binomial theorem. So I'm going to go back to what we were able to do so far. You should be able to do something like that, for example, and expand it out and find the 6th term. In fact, you should be able to find all the terms. Okay, I don't expect you over a weekend to be able to snap that right, be able to just say, here's the answer. But what if I give you this one and say, do it to the 3rd power, and I'll remind you, there are always one more term than whatever the power is, okay? Then don't even worry about the coefficients. They come from Pascal's triangle, which for now, and until I tell you later how you can do that better. But I think the best way to do this is to just start with the x, and then what do I put on it? The 3rd. Good. And then what's the next one got? An x to the, say it, 2nd, and then an x to the 1st, and then an x to the 0. So that's just slowly descending. Now use a different color and put all the y's in there. This will be y to the not 3rd, y to the what? 0, y to the 1, y to the 2, and y to the 3. Okay, good. Now, how do I get those coefficients? I taught you that the Pascal's triangle, which is kind of cool, 1, 1, 1, 1, 2, 1, 1, 3, and this is coming from those, and this is making a 3, and this is a 1. That system will work. So this has got 4 terms, so I need to use that one. So I need this. It'll be a 1 and a 3 and a 3 and a 1. And I just put pluses in between them, and there we go. That's how you get your answers. Any questions about just simple expansions? Okay, so let's see if you really can do that when I change this to like a 2x. Do you get that that will mean I will have a 2x in parentheses to the 3rd? Because that 2 has to also get cubed. All right, so why don't you try one like that? Here we go. 2x plus, let's say, 3 to the 3rd. Expand it out. Pause for a second while you do that. Okay, so here's how this should have gone. You start with a 2x parentheses to the 3rd. Notice that is not 2x to the 3rd. It's what x to the 3rd? No, it's not 2x to the 3rd. What is the answer when you're done doing it? 8x to the 3rd. Okay, that's important to get. All right, the next one's 2x in parentheses to the 2nd, 2x in parentheses to the 1st, and 2x in parentheses to the 0. And then I go through with the other one, which is the 3's, and I go say times 3 to the 0, which really doesn't do anything because that's just 1, times 3 to the 1, times 3 to the 2nd, times 3 to the 3rd. So what we do today is we ask you genius things like, what is the coefficient on the 3rd term? Do you get by doing all the terms? It's really not too tough to just go back to the 3rd term and say, oh, I guess I only need the coefficient on that. Remember, coefficient means like a lead number on it. So when I actually multiply that all out, do you get it would be 2x to the 1st times 9, which makes 18x to the 1st? Uh-oh, what's going on? Oh, okay, I haven't put Pascal's numbers in there right. You're right, you're right. So far, it's 2 times 9 is 18, but now I have to put in those Pascal numbers. You're right. Okay, it'll be 18 times whatever the Pascal number is, which happens to be 1, 3, 3, and 1. I have this one memorized, but if I didn't, I'd just make the little Pascal's triangle, and I'd grab that row that has 4 terms. Okay, sorry about that. So it's 9 times 2 is 18, and 18 times 3, it'd be 48. Is that right? 18 times 3, 30. Yeah, you're right. 8 times 3 is 24. I was trying to do it in my head. 54. Okay, who had 54 for your answer? Okay, good. Sorry about that. So that's just a normal one that I wanted to show you without the binomial. Now, let me show you the binomial and how you'd use that. Okay. The binomial has a big summation sign. Everybody write this down because it'll help you to follow it. And it goes from n equals, actually, sorry, j is down there, equals 0. And they want you to start with a 0 down there. And that's important. It's different than normal. We usually start with 1. And it's n up here. In our problem, that's going to be a 3, but for later. Then this next little part is what replaces Pascal's triangle for finding those coefficients. Just like the numbers from Pascal's triangle came in and were written here in blue, this can tell us that for each term. And it's n over j. So in our problem, what would n be? In this problem right here, it's really important. What's n? N is 3. So this is our n value, and that's just going to go in everywhere you see n. And j is going to change depending on what term you're on. Okay, then this next part is the a. This is assuming that we have an original equation that doesn't look like this. So let me clean this up a little bit. I'm going to move this down. I'm going to move all this down too. It's assuming you had an original problem of a plus b to the n to give you. All right. And it's a to the n minus j. And it's b to the j. All right. This really looks like a whole bunch of mumbo jumbo until you actually try one. So we already have all of our terms, right? Let me just show you how this first term for this problem would have come about. This summation thing just means you're going to do a whole bunch of these. You're going to stick in 0, you're going to stick in 1, you're going to stick in 2, you're going to keep sticking in numbers until you finally have done all of them. If that's a 3 in this case, we're not going to have 3 answers. We're going to have 4. Why don't we have 3 terms? Because you stick in 0 and 1 and 2 and 3. Do you get how that gives you 4 terms? You're going to stick in 0 and 1 and 2 and 3. It's always going to give you 1 more of these terms than whatever n is. Okay, so if it's got a 3 here, it'll have 4 terms. All right, so how do we get this first term right here? Using this formula right here. Well, it's n over j. Okay, what's n? Hint, it's always the same. What's n in this problem? 3. It's going to be 3 throughout the whole problem. No matter which term we're on, n is always 3. But j is going to change. For this first term here, this first one, it'll be 0. What'll it be for this one? 1. And this one, it'll be, and this one, j will be 3. Okay. So on this first term, j is 0. It says start with j is 0. Okay, so I'm going to say a 0. Then that is giving me the lead coefficient, the number that will be in front, like this. Instead of Pascal's triangle, I can get that 1 by doing that 3, 0 thing. Do you remember how that translates to 3, choose 0? And do you remember how that translates to 3 factorial over 0 factorial? And then a 3 minus 0, which is 3 factorial. And the weird thing is 0 factorial is equal to 1. All right, so this is really 3 factorial over 3 factorial, which obviously is the exact same thing. So it cancels, and the answer is what? 1. And that's how you get the 1. Do you get why Pascal's triangle is a lot easier than that? To get the 1. But it works. Yes, sir?
Doesn't everything in Pascal's triangle already start with 1?
Yes. redundant in that what? Are you just saying the first term's always going to have a 1 as its lead coefficient? Is that all you're trying to say? Yes. Every problem that you ever do will have a 1 here. Don't forget, though, that the answer isn't 1. It's actually 2 to the third times 3 to the 0 times 1. But anyway, okay. So now, how could we have gotten this guy, the 3? I know Pascal's triangle could have told us that 3. But instead, we could have done a little this thing. And it's always whatever number's up top here, 3, over, this is the tricky part. If it's the second term, you don't put a 2. You put a 1. So what's 3 choose 1? Etc. Figure it out. What's 3 choose 1? Write it down. If you've got it already on your paper, good. Write it down. Do you not remember how to do this? I just need you with me, not just watching me. So this is 3 choose 1, which is 3 factorial over some other stuff, and hopefully you can figure out what they are from what I taught you on Thursday. Okay, what are the other things that go on the bottom? There's a 1. You always put one of these on top, one of those on the bottom, and then one more thing, 3 minus 1. So that's really 3 factorial over, do I have to even write 1 factorial? It's just 1. So then what's 3 minus 1? That's 2. 2 factorial. So really that's 3 factorial over 2 factorial. The answer is not 1. Everything cancels except what? The 3, and therefore the answer is 3. All that work to figure out something Pascal's triangle could have told us. Okay? But did you really want to do the 117th term of Pascal's triangle? That'd get a little tedious. This would work every time. Okay, so say I had something, and I'm not going to say what's inside it, but it was to the 8th. How many terms will it have? 9. Good. On the first term, instead of using Pascal's triangle to figure out the 1, I guess we know it's going to be 1, so let's not even do that. That's kind of lame. How about do the second term? In the second term, first term we already know it's going to have a 1 as the lead from Pascal's. So the second term, you got to do this little dealy about. What would you do, Mr. V? What goes here? What goes here? Yes, and what is n in this case? 8. And what is j if you're on the second term? Yes. If you don't put in a 2, it's tempting, but it's always 1 less than that. So it's 8, 1. 8, choose 1. Do you get how we got the 8 and the 1 there? By the way, for the next term, it's going to be 8 again. It's always, that n number is always there. That part's easy. And this number is always 1 less than whatever term you're on. So if you're on the third term, you don't put a 3. Put a 2. Would you figure out those next couple coefficients for me? It keeps you from having to make Pascal's triangle from the beginning, because you'd always have to make Pascal's triangle from the very beginning, and it would take a lot of writing to get to some of these. It'd be on the 9th line of Pascal's triangle. All right, what's 8, 1? Well, it's 8c1. So it's 8 factorial over a 1 factorial. That part's easy. And then it's 8 minus 1 is 7 factorial. So pretty much everything cancels except the 8. So the answer is 8. The lead coefficient on this one would be an 8. Raise your hand if you got an 8 for that one. Okay, good. Would you please figure out what 8 choose 2 is? Because that would be the lead coefficient from Pascal's triangle for the third term. Figure out that right there. And I'd like you to compare it once you're done. And if you don't know what to do, ask the kid next to you. For 8, choose 2. Pause while you give that a shot. Okay, here's how you do it. 8 factorial over 2 factorial with an extra, quiet please, 8 minus 2 factorial, which is 6 factorial. So then really this is 8 times 7 times 6 times da, 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 all over, don't. 2 factorial, which is 2, and then 6, 5, 4, etc. That cancels that, and really it's 56 divided by 2. What is 56 divided by 2? 28. All right, good. So 28 is the number you could have got off Pascal's triangle, but now you know it's a 28. Does that mean that the lead coefficient is for sure 28? No, because it's very likely we're going to times that by something. All right. Now, here's another one. 3y plus 1. No, make it 2. 3y plus 2 to the third. I want to know what the second term is. The whole second term. The x, the y, actually there's no x's, the y, then the number from Pascal's triangle, or the number from the binomial theorem, whichever you'd rather do, and then multiply it all out. What is the whole second term? First term's too easy. What would the second term be? And by the way, I happen to know there's 4 terms in this, because if there's a 3 there, power, there'd be 4 terms. I'll pause while you give that one a shot. See if you can all figure out the second term of this and compare it with the person I paired you with. Tell me how to do this one. Just this one, but although you would start with 3y, how would you start? Just tell me how to start. Yep. So this got to have a 3y to the second in it. Good. Why did I just make a tragic mistake right there? Yeah, and therefore that 3 will stay a 3. It's supposed to get squared like that. Good. Okay, so there better have been a 9 as part of your answer. Okay, keep going. Yeah, we can just, I guess, it wouldn't hurt to just do this. 2 to the what? And then we make it go up, right? So this next one will be 2 to the, all right. And now we need that number from Pascal's triangle. I'm curious, did you use Pascal's triangle? Okay. In which case I go like this: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and that's the one I'd use, right? 1 through 3, 1. So therefore this needs a 3 to come out of Pascal's triangle and go right there. Now, you're supposed to know how to do it the other way too. Just so you know, that would have been what over what? 3 on top. It's very easy. It's whatever this number is. Over what on the bottom? Just don't say it's the second term, so I should put a 2. Instead, you should put a what? 1. So it's 3 choose 1. And 3 choose 1 is equal to 3. That's how you could get that number. Now, for those of you that are determined, I'm just going to always use Pascal's triangle. What if I change this to 3y plus 2 to the 17th power? Get what I'm saying? The second term will be very easy for me to do. So, just a second. First, let's do this one. Final answer, 3 times the 9 times the 2. 9 times 2 is 18. 18 times 3, 30. Is that the 54 again? Okay. So 54 y squared was the whole term. Raise your hand if you had that right. Okay, good. So, how about this? Now I'm going to change it to, it's the 17th. You really want to make Pascal's triangle out to that? Go for it. But I think it'd be a lot easier to do that little parenthesis thing. Not going to be a 3 in front anymore, is it? So what are the numbers that go in there? Miss R? The little parenthesis thing would be what over what? Yep, and then it's not the second term. I mean, it is the second term, but we don't put a 2. There we go. If you haven't figured this pattern out yet, 17 things, and I choose them one at a time. How many can I choose? 17. So that's equal to 17. Done. See how that wasn't that bad? And it's way better than trying to draw out Pascal's triangle to like the 34th row or whatever. Okay. Okay. So then, here's a typical question from today. 3x minus y to the fourth. Only find for me the third term. Now you can do, you can start term 1 and term 2 to just kind of get the pattern down, but just all I need is the third term of this. I would actually, for me, start by doing like 3x quantity to the fourth, 3x quantity to the third. I would actually write those out until I kind of got the pattern down. Then I go, oh, which term was that I want again? Which term did I tell you? Third term. It's just that I really wouldn't focus hard on calculating out the first and second term because all I really care about is the third term. And here's the third term right here. So Mr. O, tell me how to do this. How are you doing it? Okay, cool. On this, what would n over j be? Over 2. Why didn't you put a 3 right there? Even though it's the third term, you don't put a 3, you put one less than that. Okay, good. So 4 choose 2. Are you busy calculating that right now? You got 4 factorial over 2 factorial with an extra 4 minus 2, which is 2 factorial, which would be 4, 3, 2, 1, all over 2, 1, and 2, 1. And the 2 and the 2 make 4, so I'm canceling the 4. So I get 6. Did you get 6? Cool. Does that mean the lead coefficient is going to be 6? No, but 6 is the number that we would have pulled out of Pascal's triangle. I'm curious, are any holdouts that still used Pascal's triangle? It's okay if you did, and that's okay. It will work as long as the numbers don't get too big. But they might on the test, so be careful with that. Okay, so then I need the rest of it. Can you help me, Mr. V? 3. I agree. To the, yes, this would have been to the fourth, to the third. This is to the second. Good. And then on the other part. Nice. You remembered negative. And this would have been y to the 0, y to the 1, and this is squared. Excellent. Now, will that negative square itself away and be gone? Yes, it will. And therefore, I'm left with 6 times 9 is 54. 54x squared y squared. Raise your hand if you had that right. Cool. My work here is done. You've learned what you needed to learn for today. So I'm going to get started with the homework now. Now, one way they ask the homework sometimes might be like this. Which term has a 54 for a coefficient? And you'd be like, okay, well, I can calculate that it can't be the first one. It can't be the second one. Maybe I'll try the third one and see. Oh, yeah, there it is, 54. Or it might say this. Which term has a y squared in it? Do you get it can't be this one? Because that one would start with y to the 0. And it can't be that one's y to the first. Oh, yeah, that one would have a y squared in it. All right, so they're sometimes going to ask you things like that. The point is, if you want to expand the whole thing out, it'll always work. But you don't have to if you know some of these tricks, like how to start. What if I was doing the fourth term? What would the little thingy in front of it be? And please don't say a 4 in it. Like, actually, you do. The top number is a 4. Sorry. And then even though it's the fourth term, we don't put on the 4 on the bottom. We put a what? A 3. So that'd be 4, choose 3. All right. That's how you get the number that would have come from Pascal's. All right, cool. So your homework looks like, oh, just out of interesting, before Mr. Pascal, who was living in 1623 is when he was born, in 1303, quite a few hundred years beforehand, so why don't we call it the Su-Su-Sua-Ye-Chen triangle? All right, well, anyway, they had this thing going. Well, I guess maybe it's just, you know, bias to go with European, and maybe it's more like, well, this was a neat pattern. I mean, anybody can add up 1 plus 1 and it makes 2, but maybe Pascal actually fleshed it out a little bit more, and instead of just having a pattern, I mean, like some little kid could have figured out the Fibonacci and gone 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. And, you know, like it's not just that they found a pattern. It's that they actually created a bunch of math behind it. So I'm not saying, though, that this guy didn't do it first because I can't read Chinese. So I have no idea if this actually has all the math worked out, not just to make the little numbers, but to see all the patterns that are in it and all the different ways Pascal's triangle can be used. So just noting that there's no reason it has to be called Pascal's triangle. Other people used it hundreds of years before him. Okay, so here is the first place that says day 1. We already did those. Here's day 2. And I want to start this first one with you. And I want to note that the only one that I'm going to have you skip on day 2. Remember, as soon as it says day 3, you're done. And the day 2 assignment is this one, number 22. You may skip number 22. Okay? So, on number 19, here's that first case of Pascal's triangle. Might be a bit of a pain to write out. 118 terms. So, they want the term containing x to the 117th. You have to use some strategery here. How would you start making all the terms? What would be the first one? It would have an x to the what in it? X to the 118. And then the next term would have an x to the 117. Do you get right away that they're really talking about the second term? Because you always take this first number and you start by putting it to the 118 and then you go 117. And we keep going all the way until dot, 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 dot. We'd be taking x to the 0. And the other thing we do is to take 2, and that 2 starts to the 0, and it goes up. 2 to the 1, this will have 2 to the second in it, etc. So really, they wanted the term that had an x to the 117th in it. That's this one. But what am I missing? Why isn't the answer 2x to the 117th? Okay, now, could we use Pascal's triangle for this? Yeah, but it would be awful. So instead, we're going to use the little parenthesis dealy bob and say it's 117. Choose, 118. 118, choose what? Choose 1. Why am I not? I'm on the second term. Why? Oh, yeah, that's right. You don't put the same term as you're on. You put one less than that, okay? And then if it's choose 1, do you get that that means it's 118? If you have 118 things on the table and you choose them one at a time, you're going to have 118 options. So the answer is 118. So it's 118 times 2x to the 117. So the answer is whatever 118 times 2 is, and I'll let you figure that out to finish it up. Do you get how I did that? I needed to kind of know the pattern. I needed to kind of know the binomial theorem because I would not get that number from the Pascal's triangle. It would have taken me forever to get that far down. Okay. This next one. The term containing x to the negative 7th. This one's nasty because it's got x's in both parts. So you can't just say, well, that's going to be the first or the second term. You're going to have to like do a little more math to figure out when x is going to be to the negative 7th. So let's just do the first term together. On the first term, we all get Pascal's triangle starts with a 1. So is there really a need to calculate that with factorials and stuff? No, it's just a 1. 1 times. And then do you get, we take the 2x to the power of the highest power we have, which is what? Come on, in this problem, 2x to the what? To the 5, okay? And then for the next term, it would be 2x to the what? Come on, help me out here. 4. And the next term would be 2x to the third, 2x to the second, 2x to the first, and then 2x to the 0. Okay. So we start by just kind of doing all the terms. And then we'll just look quick and see which one of them is getting close to having a total of x to the negative 7. I can't tell just by this because it has x to the 5th, but I have other x's coming in, so who knows? So the next one I'm putting in is those negative x to the negative 3rd to the power of 0. Negative x to the negative 3rd to the power of 1. negative x to the negative third to the power of 2. And now I can start actually putting these together and saying which of them would have an x to the negative 7. This would have an x to the 5th and an x to the negative 3rd. And what do you do to those? You add them. 5 plus negative 3 makes what? X to the 2nd. So does my first term qualify? No, it's got x to the 2nd, not x to the negative 7th. That's out. What about the next term? That looks like it's got potential. X to the 4th and an x to the 3rd could make an x to the 7th, but it's actually, you're supposed to add them. So what's 4 plus negative 3? It's x to the 1. That didn't work. How about this next one? X to the 3rd and an x to the negative 6th. What's that one going to be? X to the negative 3. I'm getting closer, though. So that one's out. You keep going until you find the term that has an x to the negative 7th in it. Got to know the pattern. So I'm not telling you the answer. You have to figure it out. I started the pattern for you. If you took all the notes so far, you're only a couple steps away. All right. This next one. Same kind of thing. Here's the expansion. The expression. And you can expand that until you eventually find an x to the 3rd term. There will be a term that has x to the 3rd. Just for at first blush, will it be the first term? Definitely not. Okay, so you could go, okay, well, it's not the first term. Would it be the second term? Nope. Figure out which term it is. Then once you say, let's say it turns out it's the 5th term. Do you get, I'm going to put an 8 and not over 5? If it's the 5th term, I'm going to put 8 over 4, and then I'll figure out its lead coefficient. That would have been from Pascal's triangle. And then I'll have to put in my 2x. And again, I don't have to write them all out. Do you get it would have been 2x to the 8th here, to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd. And then this negative 5 is going to be put to the, well, it would have been to the 0, to the 1, to the 2, to the 3, to the 4, to the 5. That, by the way, does match up with the term. I don't know if you've noticed that. I'm on the 5th term. This number right here matches up with the term. So if I'm in the 5th term, the second thing, as it's going up from 0, 1, 2, 3, or wait. That doesn't match up with the term. So one less than the term. Yeah, my bad. Sorry, I thought that matched up with the term. Okay, and if this was the one that I needed, it would have an x to the 3rd in it. And look at that. It has an x to the 3rd in it. I wasn't just doing a random one. All right, so only like a couple more questions. When you hit it, it'll say day 3. Stop right there. Don't do any day 3s. That's going beyond what we need to know. All right, so what's the next couple days look like? First of all, we did binomial today. We finished binomial today. We will definitely review a couple of things, but and you're going to be doing one more topic before we are ready to test. Test isn't until Friday, and it's only Monday, right? So we have one more topic, and that's it. It's called proving things by induction. So I'm going to teach you that mostly all tomorrow. Then review it a little bit the next day and start the other review. Then Thursday will also be all review for your test. And then the final will be, not the final, your test on this will be on Friday. Don't forget, the take-home final is due Wednesday. How many of you are already done with it? I'm curious. Quite a few hands. Okay, good.
3/4.
That's all I have for you for today.